All right, folks, welcome back. Welcome to what should hopefully be the final episode of the series. If you're watching this in order, where we left off in the last video was we had spun up our complete multi-site EVPN topology, which included the multi-site domain with 3 child fabrics under it, the DC1 fabric, the DC2 fabric, as well as the intersite network. So let me share my screen. So this is pretty much where we had left the deployment. So as I said, you can see the child fabrics are now all incorporated under the MSD, and we had the various networks attached to the border gateways in DC1, the border gateway spine in DC2, as well as the leaf switches and their corresponding ports. So based on the topology here, okay, there we go. So based on the topology, we had attached, the various VLANs to the interfaces hanging off the leaf switches. So we're at the point where we need to do some verification, and we can start to do some connectivity tests as well. So if we start with the command line, so let's look at DC2 for a second. So DC2 leaf 01. So if we hop over to DC2 leaf 01, let's start by doing a show MAC address table. So what we should see is on port 4 of leaf 01, we know that we have this end host with IP address 10.0.0.21, and he should obviously have a MAC address as well. So what we're looking at from the leaf's perspective is off port 4, we see that the MAC address ending in 6810 belongs to that end host. So if we go to that end host, we can verify that real quick by doing a show IP, and we can see that in fact the MAC address is ends in 6810. So that's good. So we're learning the basic MAC, right? Obviously. Now the next step is we should have the show NVE VNI. So this leaf switch should have the network virtualization edge interface. It should be in an up state, and we should be essentially talking to our border gateway spine in this particular case, which is DC2 spine 01. Okay, so if we go to DC2 spine 01 and we do show NVE VNI, so we should see that we have our NVE peers as well. So the other command you can run is show NVE peers. And we can see that, let me do this, term with, I think 511, I think. Okay, so that's a little cleaner to look at here. So we can see that the border gateway spine has all of its NVE peers, right? And we can see their corresponding IP addresses. So if we go back to DC2 leaf 01, and we were to do a show IP interface brief, we can see that based on spine 01, so he's got peers with the 254, 2, 3, and 2 and 3 in DC2. So it's going to be these guys. So 2 and 3, right? So we can see that he's got a peer with leaf 01, and the .3 should be leaf 02. So that's good. Now, if we were to we need to check our BGP table to make sure that this border gateway spine is in fact learning the MAC address of the end host hanging off port 4. So we can run the command show BGP L2 EVPN summary for starts. And we can see that we have peerings with 4 neighbors, okay? So in this case, we can see that 2 of the neighbors are residing in AS 65002, which is data center 2, and that's obviously going to be leaf 1 and leaf 2, okay? And then the other 2 are in 65001, and that's riding through the ISN to the DC1 border gateways. All right, so far so good. We have the path is we're working our way over to DC1. But let's hit the up arrow and let's get rid of the summary. And let's just see the complete table that we've essentially learned. Okay, so we can see it's fairly large in size. It's not huge, right? But from a lab perspective, we can see it's got a lot of stuff in it. So the MAC address was the 6810, okay? So we can see here that we're learning the 48-bit MAC address of 6810, okay? We're learning it from .2, which we know is the leaf switch, okay? So we're learning the layer 2 MAC address information on the border gateway spine, which is the last exit point before we head over to DC1. So now we need to go over to DC1, and we can go to either border gateway, okay? And essentially just kind of run the same commands there, right? So if we go to border gateway 01 and we do show BGP L2 EVPN summary, so we see that we have the 2 spines in DC1 based on the autonomous system number, and we can see that we have the border gateway spine in DC2, which is the box we were just looking at. So if we hit the up arrow, get rid of the summary, we should see pretty much the same information that we just saw on the DC2 border gateway spine. And we can see that this is the L2 VNI 30,000. This is the one we're looking at. So 6810, we can see that we're learning the 48-bit MAC address of the host that hangs off port 4 in DC2 all the way over in DC1, okay? And what we can see here is the next hop of 10.10.03. So if we go back to spine 01, okay, so we can see that the next hop of that advertisement was coming from 10.10.03, which is in fact the DC2 spine 01. So that looks proper, okay? So now if we go back to that DC1 box, and we're going to go hop by hop, right? So I'm going to move my terminal over, and if we go to, let's just say DC1 spine 01, and we do show BGP L2 EVPN summary, or I'm sorry, the leaf. Let's go to DC1 leaf 01. Show BGP L2 EVPN summary. All right, we see that we're paired with both spines at this point, which is proper. And then we should see, if we hit the up arrow, ditch the summary, we should see the MAC address for 6810 under the route import tag that we used of 30,002. So this 30,000 was the shared L3 VNI. That's if you want to route packets to that MAC address or that IP address, it's going to use the L3 shared VNI. But if you want to bridge or switch the traffic from the same subnet to, from bridge it, right? It's in the same subnet. You need to look at this route distinguisher here. So we can see that under there we have the 6810. We see that we learned it from our local border gateway in this case. So that's going to be border gateway 1 or 2 in DC1. So if we just double check that. So it turns out that that's border gateway 1. So border gateway 1, obviously we just looked at him. He learned the route. He then turned around and advertised it down to the leaf switch. So the leaf switch, if we do the final verification of show MAC address table, what we should see is an entry for 6810, which is, again, all the way over here in DC2. So we have full end-to-end control plane, I'll call it reachability or verification, that the control plane is working end-to-end. Now, that should mean that, ping connectivity works as well. So let's go ahead and try that. Okay, beautiful. So he has full connectivity to 10.0.0.21, which we know is inter-fabric connectivity through the ISN. So that is a beautiful thing. So far so good. So now the next thing we need to kind of verify is in DC2 10.2.101.21. So this is that locally significant subnet. Let's go ahead and assign that IP address to that end host. All right, so we've done that. Now, as soon as I did that, it should generate, the ARP message. So if we were to go to DC2 leaf02 and do show MAC address, okay, so we see 6814 in this case, all right? 6814 hangs off port 5. That should be that end host we were just on. So 6814, yes it is, okay? So what we want to see is over in DC1 on leaf01, we want to see if we see an entry for 6814 in our MAC address table. Okay, perfect. So we can see that a minute ago it wasn't there because I had powered on the machine and we put the IP address on it. So now we can see we have an entry. It's learning it through our local border gateway over the ISN from DC2. So the question here now is for this end host, 10.1.101.11. All right, so we've got an IP address with our default gateway. The question is, can we ping Okay, that looks good. So we can ping from our local 10.1.101.11 box, right? We can ping over to DC2, which is essentially now it's routing the traffic through the L3 VNI as opposed to switching it across the L2 VNI. So we can trace that path as well. So let's just look at DC1 Leaf 01. So if we go to DC1 Leaf 01, we know that it was the 6814. So if we do show BGP L2 EVPN and we look for the 6814, so here's the L3 VNI, okay? So the L3 VNI has the entry for 6814, which is proper. So if we basically if we just kind of follow the path and we go over to DC2, we should see all the same entries across the devices, right? But the fact of the matter is you want to see it under the L3 VNI because that's going to be the routing portion as opposed to the bridging or the switching portion. So yeah, so like I said, in summary, hopefully, let me just log back in. This was a shorter video. It's just some quick verification. Like I said, I'm not going to go into great detail on all the underlying VXLAN stuff. I think we've touched on the major bits and pieces of it, but hopefully you got something out of this. NDFC is fairly powerful in my opinion. It was really cool to kind of learn it and go through the motions and understand the workflow and how to kind of spin up this topology. So I think all in all, with looking back at this topology, we've got 10 devices in total, all mostly 2 data centers connecting back to back through multi-site, and I think we spun the entire thing up in probably somewhere around like a 2-hour mark, something like that, when you kind of tally everything up and cut out the all of the explanation and the walkthroughs and stuff. So again, fairly powerful to be able to do that. And the overall management of the platform is pretty intuitive as well. So once you kind of come back in here and you need to manipulate networks and kind of spin things up, bring things down, whatever, it's like I said, it's pretty intuitive, and it does all the hard work for you, which is deploying the configuration. So again, I hope you enjoyed it. Please give me feedback, good, bad, either way. Let me know how I did, and I hope to see you guys in another series in the near future. So thank you so much. Take care.